Happy greetings. So today I'm going to discuss with you rate of the reaction from chemical kinetics topic in 12th cbse board. Let's start our discussion. So first we are going to start the discussion with the definition of rate of the reaction. What do you call as the rate of the reaction? Actually, the rate we mean the speed of the reaction. So in how many ways we are going to calculate this? So the first way, the first type of the rate of the reaction, we are going to say it is an average rate of the reaction. The another one we call it as instantaneous rate of the reaction. So now let us talk what is the difference between average and instantaneous rate of the reaction. So by considering a small problem, a student takes 20 minutes to reach school by car. The distance between the home to school is 10 kilometers. Find the average speed of the car. So they're asking you to find out at which speed the car is going, the average speed of the car. So how will you calculate? So average speed of the car by considering this formula, distance by time. So you know very well that what is the distance given here? It's a 10 kilometers given. How much time he takes to reach school? 20 minutes. So let me write it right here. So if I simplify it, so I will come to know that the car covering 0.5 kilometer per minute, right? So this is actually we mean the average speed of the vehicle throughout the journey is 0.5 kilometer per minute, which is constant. But if you consider instantaneous rate, so we just discussed in the first slide about average rate and instantaneous rate. So just now what we have found, the average rate of the car, average speed of the car. So it is going to be same throughout the journey. But when when the student travels from home to school, he come across a signal at 8th minute. So what will happen? So the car will be at rest. So he couldn't cover any distance. So the distance covered by the car is 0. So no matter how long he stopped at that signal, so that instantaneous rate of the reaction at this particular time we can calculate as 0, right? So what we can say is, if you talk about the instantaneous rate of the reaction, so it is going to change from time to time. So this is the first understanding you need to have. So now let us define what is the average rate of the reaction. If you consider the average rate of the reaction, so what you need to take is the appreciable interval of time to be taken. Let's now have the discussion by considering a simple reaction. So here the R, what we represent is a reactant. What we call P is nothing but product. So you know that what number I have written here, 1. 1 is by default, 1 is there. So 1 represents, we have taken 1 mole of reactant and then it gets converted to 1 mole of product, right? So what I am going to do is, so the reaction started occurring. Initially what I start with the reactant at time 1. At time 1, I'm just measuring the concentration of the reactant. So I'm going to say the concentration of the reactant by representing this way. Here the square bracket indicates concentration. So whatever I have written within the square bracket is one more about which one we are talking about. So I'm talking about the reactant. So I have to read this as concentration of the reactant. So what about this one? I have to say that it is at time 1, at time instant 1, or first time interval, right? Then I'm going at that time, at time t1. So the product concentration is p1. The concentration of the product is p1. So I'm going to consider the next time instant called the t2. At that time, the measured concentration of the reactant is R2 and the measured concentration of the product is P2. So let me go to the next one. So from this, what I'm going to find out, I'm going to find out what is the rate, at which rate the R is going to disappear. You know very well that when you take the reactant, when it gets converted into product, so the concentration of the reactant is going to decrease. Concentration of the reactant keeps on decreasing. At the same time, concentration of the product increases, right? So that is why here we mentioned that decrease in concentration of R, right? So with respect to the time, so the decrease I observe with the time interval. Let me write, instead of decrease, I'm going to mention this as what minus. So after that, so I'm going to observe the change. For to mention change, I'm going to use delta. So the delta refers change. So the square bracket refers concentration. Whatever I have written within that, so what we have read as, so change in concentration of the reactant. So this is observed when you have taken what was some time interval, the change in time. Delta t means change in time. So I'm going to just write how to find out delta R2. So I have considered two instants in the previous slide. So the time instant 1 and time instant 2. At time instant 1, the observed reactant concentration is R1. At time interval 2, the observed reactant concentration is R2. So now if I find the difference in change in reactant concentration and divided by the time taken, I will be able to calculate what is the rate of disappearance of A. So you may have the question that why do we write the negative sign here? As I said before, the negative sign indicates there is going to be the decrease in the concentration of the reactant. Let's now go to the next. So far we have been discussing about what happened to the concentration of the reactant. Now let us see what happened to the product. So as I mentioned before, when reaction proceeds, the concentration of the reactant keeps on decreasing. At the same time, concentration of the product keeps on increasing. So that is why we are writing here increase in the concentration of the P. So this increase is observed during certain time interval. So for increase, I'm going to use plus, right? So the change in concentration, I'm going to represent as delta P divided by delta T, right? So what does that mean? How to find out this? So the same, what I have done is, so I have considered time interval 1. At the time interval, the observed product formation, the concentration of the product is P1. At the time interval 2, the concentration of the product P2. Now if I find the difference in concentration of the product and time taken, I will be getting at the speed of or rate of appearance of P. So here we have this positive sign, so that indicates what happened to the concentration of the P. So P is keeps on increasing. So the plus sign indicates increase in concentration of the product. So now we are going to just plot and see the concentration of the reactant versus time. You may have the question why we need to plot. So at the end of this, you will learn why we need to plot this graph. What's the purpose of plotting the graph? So let me consider our time equal to 0. So we have plotted concentration of the reactant on y-axis. So this is the concentration of the reactant. So the naught represents what is the initial concentration with which I have started, right? So when time increases, so let me consider T1. So what is going to happen? What is happening to the concentration of the reactant? Concentration of the reactant decreases. So when it decreases, so I find at the time T1, the concentration of R1 is here. Now let me move on to the next time instant. So I'm going to just observe at the time T2, the concentration of the reactant is T2. So you can clearly see as time increases, the concentration of the reactant keeps on decreasing, right? Okay, so if I just keep on doing it, I will be getting a graph like this. So initially the concentration of the reactant was high. So when we move on, when time increases, concentration of the reactant goes on decreasing. Got it? Now, what I'm going to do? So what's the use of plotting this graph? It's for finding average rate of the reaction, right? How to find out? So what I have done is, what done here is, how to find out? So what I have taken in y-axis, I have taken concentration of the reactant. So the change in concentration. So what I have taken in x-axis, time, so change in time. So this is nothing but the slope. If I find the slope, the slope will give me, right, the average rate of the reaction. Got it? So here delta R, how to find out delta R? We can simply say that R2 minus R1. So we have a negative sign here indicating that the concentration of the reactant keeps on decreasing. So here I have written delta T, change in time, right? So by plotting the graph, I will be able to calculate the average rate of the reaction. Got it? So this difference, I can say that it is in delta R. This difference, I can say it is delta T. I can easily measure it. And then how to measure delta R. So R2 minus R1. How to measure delta T, T2 minus T1 here, right? So if at all, if I draw the plot for graph for product, so do you know how the plot will look like? So initially there was no formation of product at all. So if I have to start from here, there was no product before the reaction starts. Once the reaction starts, right, I consider the time t1. At that time t1, the concentration of the product found to be p1, and I consider another instant t2. So concentration of product is P2. If I just calculate, if I just join the points in the graph, points, I will be getting a graph like this. So what we are going to now do? So here the same way I'm going to calculate the average rate with respect to product I'm going to find out. Right? So this difference, this difference gives me the delta P, change in concentration of the product. So this difference gives me change in time. So I can write delta P as P2 minus P1, delta T as T2 minus T1, right? So let's now have one question regarding what we have learned so far. So the negative sign to the rate of the reaction with respect to the concentration of the reactant dash in duration period of reaction. Can you now guess? So negative sign of the rate of the reaction with respect to concentration of the reactant. So you know very well that as time increases, the concentration of the reactant keeps on decreasing. This is what we were talking about. So when you plot the graph, so you have seen like this, right? The concentration of the reactant. So here we have plotted concentration of the reactant. Here we have plotted time. So as time increases, the concentration of the reactant goes on decreasing. So to indicate the decrease, we use the sign negative. We use negative sign. Now let us discuss few questions regarding rate of the reaction. So for the reaction R converting into P, the concentration of the reactant changes from 0.03 molarity to 0.02 molarity in 25 minutes. Calculate the average rate of the reaction using the unit of time both in minutes and seconds. So you need to express the time both in minute and second. So I hope you would understand what the question meant. The initial concentration of the reactant is given to be 0.03. Now it gets converted to 0.02 molarity. For this conversion, for this change, it takes 25 minutes. Now let's calculate the average rate. Now how to find out average rate? Because they are asking you to find out average rate. So delta R divided by delta T. So the change in concentration of the reactant. So the final concentration is this, minus initial concentration was this, and then this has taken place, I mean, in the time interval of 25 minutes. So if I just calculate it, so what I have just found is, look at this value. So I have just substituted the time in which unit minutes, right? So the answer I will be getting in mole per liter per minute. So what does this mean? So here we used molarity. Molarity formula is number of moles per liter, number of moles per liter. Okay, so that is what we have written, mole per liter. So the unit of time expressed in terms of minutes, right? So now we are going to express the average rate in terms of second. So we have been given 25 minutes, so they're asking you to express average rate in terms of seconds. So what should we do here is just converting minutes into second by multiplying with 60, right? So if I simplify it, you will be getting 6.67 into 10 power 6 mole per liter per second.